So we want to find all the values of x where the series converges absolutely. So we have to check for the interval convergence. So we're going to use the ratio test. So we're going to get the nth plus 1 term and divide it by the nth term. So notice that this is going to 1 because as n goes to infinity, this is similar to n squared over n squared, which is 1. So I'm just left with 2x plus 3, and we want this to be less than 1. So we have an interval of convergence from -2 to -1. Then we need to check our endpoints. So what we're going to do is we're going to substitute both -2 and -1 back into our series wherever we see an x. So at x equals -2, my series becomes an alternating series. Okay. So notice that this isn't going to pass the alternating series test because as n goes to infinity, this is going to 0. So I'm going to use the nth term test, and this is going to diverge because it's equal to -1, which is not which is equal to 1, not -1. It is going not equal to 0, so it's going to diverge. When x is equal to -1, it just becomes n over n plus 2, which is again using the nth term test. This is going to diverge because it's not equal to 0. So that means that my endpoints are not included in my interval of convergence. So where does it converge absolutely? It only converges absolutely from -2 to -1. Part B asks, where does it converge conditionally? There's no places that it converges conditionally because it diverges on both endpoints. Oops, so it should be none.